by IITian channel. In this lecture, we will be discussing about the very important topic on matrices, the trace of a matrix, determinant of a matrix, eigenvalues of a matrix, and relation between eigenvalues and determinants, and about Pauli matrices. You might have heard about the Pauli exclusion principle in your physics, and we will be talking about the Pauli matrices in this lecture. It's a very, very important lecture, and please pay full attention to it. And if there is a value addition to your knowledge because of this lecture, then you please subscribe to my channel. And we will also talk about the transpose, and these are all will be talked about by taking the example of a particular Pauli matrix. Let's proceed further. Here, what is the question matrix given? Let the matrix be A is equal to 0 minus I 0, and we will try to analyze now one by one. Analysis. A is equal to 0 I minus I 0, which implies 1. What is the transpose of this? Transpose is equal to transpose of A is equal to A transpose, that is, rows will become columns and columns will become row. The first row is 0 minus I, that becomes the first column. And second row is I 0, that becomes the second column. This is the transpose. Now, second, what is the trace of the matrix? What is the definition of the trace? Trace of a matrix is equal to, it is denoted by T or A, that is equal to sum of the elements in the principal diagonal. In the principal diagonal. This is very, very important definition. Please remember this. Very important definition. Trace of a matrix. It can be asked either in the JEE Mains or Maths Olympiad. They may give some 3x3 matrix, 4x4 matrix, and they may ask you to find out the trace of a matrix. Trace is nothing but sum of the elements in the principal diagonal. Then here, what is the trace of this A? For the example, trace A is equal to sum of the principal diagonals is 0, 0. Sum of the principal diagonal elements is equal to 0, 0. That is equal to 0. First, the transpose of a matrix we have found out, and the trace of the matrix. Trace of the transpose matrix, trace of the transposed matrix is also 0 plus 0, because this is the principal diagonal. This is the principal diagonal. This is also 0. This is, we are talking about the properties of the particular matrix which is given to us. Now, let us go for the determinant. What are the properties of the determinants of these two matrices, A and A transpose? For A, determinant is 0 minus I 0. You have to do the cross multiplication. I have already told you what is determinant. then put a minus in between them. 0 into 0 minus I into minus I. What is I into minus I? It is nothing but a plus 1, because I square is equal to minus 1. Minus I square is equal to plus 1. And I is equal to square root of minus 1. Then I into minus I is minus I square, that is 1. That means 0 minus 1, that is equal to minus 1. This is the determinant of the matrix A. Then determinant of matrix, transpose matrix. What is the transpose matrix? We have found out here. 0i minus I 0. 0i minus I 0. What is its value? Cross multiplication 0 into 0 minus I into I. Please don't change the orders. That is equal to minus I square is 1. 0 minus 1, that is equal to minus 1. That means for this matrix, determinant of A is equal to determinant of A transpose is equal to minus 1. Next, the numerical value is unity. Let us see. Next, let us find out the eigenvalues. Eigenvalues for both the matrices A and A transpose. First, for A is given as A is equal to 0 minus I 0. Then what is the characteristic equation? I have already told you, characteristic equation is A minus lambda I is equal to 0. Here, because it is a 2 by 2 matrix, I is equal to 1 0 0 1. Then characteristic equation becomes determinant of A minus lambda I is equal to determinant of A is 0 minus I 0 minus lambda into 1 0 0 1. That implies characteristic equation is for A, it is for A, that is equal to determinant of 0 minus lambda minus I minus 0 minus I plus 0, 0 minus lambda into 1 minus I minus lambda into 0, because we should not, even if it is 0 also, we should not play with order. This is 1 and another is minus I minus lambda into 0. Here it will be I minus 0 and another is 0 minus lambda into 1. That is equal to minus lambda minus I and minus lambda. This implies this is equal to minus lambda into minus lambda is lambda square minus minus I square. That is equal to lambda square minus 1 is equal to 0. That means lambda is equal to plus or minus 1. The eigenvalues. What is the one eigenvalue? Lambda 1, first eigenvalue is plus 1 and second eigenvalue is equal to minus 1. Then what is the product of eigenvalues? Product of eigenvalues, it is very, very important, is equal to plus 1 into minus 1, that is equal to minus 1. What is the value of minus 1? This is nothing but determinant of A. Very important observation. Determinant of a matrix is equal to product of the eigenvalues. Determinant of a matrix A is equal to that given matrix product of eigenvalues. Very important derivation. What is the sum of the eigenvalues? Sum of the eigenvalues plus 1 minus 1, that is equal to 0. That is equal to sum of the principal diagonal elements. Principal diagonal elements. That is equal to trace of the matrix. You just see how many properties we are deriving from this. Now, what we have got? Trace of the matrices. These matrices are called traceless matrices. We have defined all these. These are all called traceless matrices. Hence, it is a traceless matrix. And this type of matrix is called as Pauli matrix. The given example, this is called as Pauli matrix. And the other Pauli matrices are 0, 1, 1, 0, this is also traceless, and another is 1, 0, 0 minus 1, this is also traceless. Then prove all the properties. Your homework is prove all the above properties. One is trace, determinant, eigenvalues, product of eigenvalues, sum of eigenvalues, for the remaining two Pauli matrices, and check if they are true for all the matrices or not. If they are not true, what are the properties are not true for all the matrices and what are the properties are true for all the matrices? This is here. Ultimately, what is your homework? Homework is other Pauli matrices. What as I told you, this is one Pauli matrix. Another Pauli matrix is 0, 1, 1, 0, and another Pauli matrix is 1, 0, 0, 1, 0, minus 1. Prove the properties of trace. Determinant. Examine. This is the homework for you. Examine trace. Determinant. Product of eigenvalues. Product of elements in principal diagonal. Sum of elements in principal diagonal. All these properties you prove for the other matrices also, and also you try to prove whether these properties are applicable to other matrices other than Pauli matrices or not. That's your homework, and let us discuss further on this in the next class. Best of luck to everybody. Thank you for listening to me. Thank you for listening to my lecture. And whether these properties are true for, if it is A, whether these properties are true for transpose also, all the 5 properties. If not, which are the properties are true, which are the properties not true. It's a matrices. Once you are thorough with the properties of the matrices, then you will not make any mistake in the examination. Be thorough, be thorough, be thorough. Try to understand the concepts. Thank you for listening to me. Best of luck to everybody in your examinations, and for NEET, JEE Advanced and JEE Mains, and also for Maths Olympiad, and I am from Maths and Science by IITian. Please share and subscribe to my channel. Thank you for listening to me. Best of luck.